In this tutorial, we're going to discuss a simple setup using MIME in order to import a geometry and mesh it for CFD++. Before going through and loading the model, I want to go over the features of the ICMP-based IMIME interface. All the ICMP-based interfaces have a menu bar with drop-down menus, some cascade, the toolbar, which is very similar along all ICMP-based software. And then we have the notebook, which is this tab-based entity. Inside a notebook, a specific software resides, so you can have multiple notebooks for cases where you are going to have MIME, CFD++, CSM++, MetaFSI, and so on. Inside the notebook, you will find the action tree. This is a wizard which allows you to set up your case, and it will basically go through a step-by-step process. As you interact with the GUI, more options will show up in the action tree. Related to each item in the action tree, you have the action panel, which is sitting here on the left-hand side. Inside the notebook, you also have the canvas. In the canvas, you basically will get all the different drawings in terms of the model or mesh and so on. And as you create families, each surface or other type of entity will be put into those families. So we will begin the MIME tutorial by bringing in a geometry. So that is the first thing that we need to do. We can, if we had previous setups, we could simply search for a configuration file. But here we're going to load a geometry. The geometry that we're going to load is going to be in parasolid format, so I will browse and go to the directory that I want. I'm already in my current directory, and I will load that geometry. After I have chosen everything in the action panel, I will click OK, and my geometry will be displayed here. It is a simple intake piston for an automobile. It has an intake pipe, a piston inside, which we'll see in a second, and we will go ahead and create a mesh in this where we have an inflow here, an outflow here, and the rest are going to be walls. You can see that after I loaded the geometry, I'm now in the next item for the MIME action tree. Here I have to put different items into family groupings. There are three types of entities that we deal with in MIME. These are entities which are of type face. For example, if I click using the left mouse button on this, you will see that it picks a surface or a face. Right-click undoes the picking. We also have entities which are vertex type and curve type or edge type. So edges, curves are the same, points and vertices are the same, and surface and face are the same. In order to pick items on the screen, there are two different modes. You can go ahead and actually there's three different modes. You can click on an item, unclick, use the right mouse button, or you can draw a box on the screen. If you start from the left side and drag the box, every item that is completely enclosed in this box will only get picked, like so. So you can see that this surface right here, this long wall surface or cylinder surface did not get picked because it was only partially inside the box. I'll right click now to undo my last selection, and I will now start a box from this time the right going to left, and when I do this, any item that this box touches, regardless of whether it's completely encased in this box or not, will get picked, like so. I will undo that. In order to pick an edge, what you can do is click on the E button, hold it down on the keyboard, and now simply choose your area, and every edge that I touch basically will now be picked. So this edge and that edge only get picked. Similar thing can be done for vertices by clicking on the V key. By default, we usually pick the face if it's clicked in a place where there's a face, edge, and vertex displayed. So what I'm going to do now is I'm going to go ahead and put items into families. The first family is going to be my inflow family, so I will choose that surface and then click on the middle mouse button, drag it into the families. That creates a family for me. Double click that family and I will name this inflow. Next, I am going to create the outflow boundary. So that will be this boundary. I will again click after I make my selection and drag that into the families, double click, and name that outflow. Next, I will have the tank boundary. The tank boundary is going to be this. And that top surface with its curve, I will drag into families, double click, and call that tank. Similarly, I am going to take this portion along with this small portion here and make sure I grab all the elements here and drag those and call that pipe. And finally, whatever is left over is going to be my piston. So I choose whatever is left over, drag it into families, and call it piston. So now I can basically go and display all the different surfaces by coming here and clicking on the middle mouse button on the families, and that displays my families based on how I've grouped them: the inflow, the outflow, the tank, the pipe, and the piston. I will now go ahead and click on OK. I do not want to run any wizards on this particular case. So now I am going to give individual sizes on the different families for the surface meshing. So here, what I will do is right click on the families and say, go ahead and display mesh sizes. And these are our current sizes. Every single family basically has the global mesh size, which is currently given as that. I'm going to make the global mesh size a little bit smaller. So you can see that I basically now have a global mesh size everywhere, which is roughly the following size. In regions where I don't make this any smaller, that once the growth factor reaches that specific size, that will be the largest size anywhere in my domain. Now, I can go ahead and resize some of these entities based on the relative size to this specific global size. I want to make the mesh on the pipe and piston a little bit smaller. So on the pipe and on the piston, I will go ahead and make the sizes relative to this 1/8 of this 0.01. And you can see that now the sizes on the wall and on the piston are now smaller. Next, we can go ahead and click OK and create a single density box, because in this region the important part of the flow field occurs in this part where the flow comes in, goes around the piston, and perhaps there's a recirculation zone here. And we want to capture that by putting a finer mesh in that region. So a density box can be created for that region. The density box control basically has the following type of structure, which you will see in other ICMP software, where one can create, edit, and destroy a specific item inside a tree, and some specific type of buttons that might show up for specific types of trees. So here I am going to create a region. It is going to be of type box. I will double click, and automatically what MIME will do is it will create a box around the entire part of the geometry that is displayed. So if I did not want to create a box around the whole thing, I could have deselected and not displayed, for example, the tank and the outflow, and my box would have been this big. I will go to the box. When I click on the box, the display will go ahead and give me some things which I can use in order to resize this box. For example, these black arrows will resize the box in X, Y, and Z. I am going to resize my box in Z. Box rotation and translation can occur using these buttons, so I can actually translate the box using these three arrows. I can rotate the box using this blue, that red, and this green. So inside this box, I am going to make a relative mesh which is 1/4 of my global mesh size. And at this point, I am not going to do anything advanced and simply create my surface mesh. I can name my configuration file. The configuration file can be, for example, piston, and the parameter file can be named piston. And at this point, the surface meshing begins. Each one of the entities is meshed, and you can see that a successful exit statement is achieved. And at this point, I have my mesh. You can see in the region where there's a density box, the entire mesh on the surface also picks up that size. And I have my fine mesh on the piston and the walls. Next, I will create a prism grid on the wall boundaries. So at this point, I will say I do want prism layers. I will use the relative growth 1 option, which basically grows prisms until a natural size with respect to the tetras in the domain are reached. I will use a first cell spacing, which is 0.1 millimeters or 10 to the minus 4 meters, and apply it to 3 boundaries, which are my tank, pipe, and piston. And at this point, I will click OK and generate my volume mesh. During the volume mesh process, initially the prism layers are grown. Once the prism layers are grown and you are given the number of prism layers, the next phase is basically the volume generation of the TETs. You can see that there is an item here which is the single box that we have, and some refinement is done in that region. After the mesh is produced, there are some smoothing operations that occur. After the smoothing operations occur, we should get a successful exit from the grid generation, and we have. At this point, I will click OK and load the volume mesh, which has about 500,000 elements. You can see that now I have prisms. The prisms basically grow out until they hit the rough tetra size in this area. So I didn't have to give it the number of layers. I'm not going to do any mesh improvement. So I will click OK. I can inspect the mesh if I want. For example, I can do a cut plane, and I can do a cut plane, let's say, at the halfway point. So I can choose a cut plane at 50% and click on the middle mouse button, which creates my cut plane. I can go and inspect what has occurred and get a feel for the type of elements, the sizes of the elements, the prisms and the tetras that are created. At this point, if I want, I can export the mesh into different formats. For example, I can export this mesh into a 3D CFD++ format. If I want to scale or translate the grid, I can do that here. If I click OK, basically a tool runs and it goes ahead and writes the familiar files that one might be used to for CFD++. And at this point, the end of the action tree has been reached. I have my CFD++ files, and now I can load CFD++ and begin my computations.